We're back with another PicoCTF challenge. This time password crack 3. Description: can you crack the password to get the flag? Download the password checker here. And you'll need the encrypted flag and the hash in the same directory too. There are 7 potential passwords with 1 being correct. You can find these by examining the password checker script. Alright, at this point in time, I'm going to drag these all out to the desktop. We understand that this is never going to work on the first run. So I'm going to just skip right to opening up the code in VS Code. Again, I like to collapse the functions until I need them. And I like to work from a high level. So first off, we can see we're going to run through to this point. Actually, let's live debug. Let's live debug. That would be the best way to go. Start debugging the Python script. We can see we're going to prompt for a password here. Then we're going to hash it. What is the value of correct password hash? Oh, interesting. Okay. So we've added a little wrinkle to this. We no longer have, as we did in the prior examples, we no longer have something like ABC where the password is directly in the file. Now instead, what we have is we have that hash file that you saw. Let me bring that up. So this is our password. It just happens to have been hashed, which means we applied a one-way function to our actual password. And that makes it very difficult to figure out what the password was without brute forcing. So just to quickly show you what a one-way function is, let's make things a little larger so it's a little more pleasant to watch. We're going to run SHA-256, and we are going to echo our password into it, so using xargs. So just to explain what's going to happen, password is going to be passed in to this one-way function, the SHA-256 function. That did not work. Let's see. Let's try. There we go. So this is a representation of password in SHA-256. If we make a minor change, say password 1, we're going to get a very different SHA-256 hash. And going back from this hash is very difficult. As a matter of fact, if you're somebody who can figure out how to do this for SHA-256, other than brute forcing it, you're going to be very famous and you're going to make a lot of money in cryptographic circles. So, hats off to you. This is what we're looking at here, is we're looking at a hash. I don't know which one, but we're looking at some family of hash. And so as a result, we're going to need to check each possibility. Really, that's the best way to find a match for the hash. So just to give you a sense of what we're doing, we're going to keep putting in guesses. So if we knew that this B68 was what we were trying to find, and we didn't know that it was password, we would keep guessing things like ABC, ABCD, and we would then check and see if the hash matched. And if it did, then we knew we found the password. This is the way most secure systems store their passwords, is through hashing. Okay, so we've established we only have 7 passwords. 7 is pretty manageable. We could go through this one by one, and we could run this and submit the flag, or the potential password for the flag. But that's not a very smart approach. Instead, let's do this programmatically. And what you're going to see is this is going to serve us well. This is basically going to solve password crack 3, 4, and 5. So we understand that at this point, we take input from the user and we say, please give us a flag. Why don't we, instead of taking this input from the user, why don't we pass it in to the function? So we will take that and we'll comment this line out by putting a £sign in front of it. And then we have this array, this possible password list. So let's loop over it. So for possible password in possible password list, we want to loop calling this function and passing the password, and that should work. So let's set a breakpoint. We'll debug, and we can see we're going to try the password that we just tried a second ago. We know that'll fail, but that's okay. The computer's going to do this. Now we're on to the second potential password, 4AA2. Again, it's incorrect, but that's okay. We're going to let this run at this point. And we find it in the last one. So let's go ahead and let's go and submit that.